Okay, so sometimes instead of making monthly deposits, knowing what that is and then determining future value, we kind of want to work the other way. So we need a future value or an account balance in the future, some goal we're trying to reach. We want to know how much should I be depositing. So in this case, we need $30,000 for a down payment on a house 3 years from now. So of course, you may not know that number exactly, but you're just sort of thinking, well, ballpark, maybe I need about 30,000. So you want to get a sense of how much you need to deposit every month if you're putting it into, in this case, a money market account that earns 0.9% APR. We can talk about the different types of accounts. You know, savings accounts have very low interest rates. Money markets are much better, but still fairly low. But your money is more accessible there, just like with a savings account. If you invest it in a retirement type of account, you got to be really careful about that. The APR, the percentages are higher, but harder to get that money out. So this is a realistic scenario, at least if you're looking 3 years from now. So our interest is going to be compounded monthly. So in this case, we're using a formula, not the TVM solver or some kind of table. This formula is going to be a manipulation on a different formula that we've seen where we know the monthly deposit. So this time we're solving for monthly deposit. It's going to be a fraction. Again, it has kind of some of the common characters we've seen. The first part of this is going to be, okay, well, what's our goal or our desired balance? So I'm just going to say goal / balance, and we mean by that future balance. What do we want to have? That'll be our 30,000. Then we need our APR over 12. So this is our period interest rate, our monthly interest rate. And then in the bottom, we've got 1 plus APR over 12 to the 12y. So y is used to denote number of years. 12 times y turns it into a number of months, right? Basically total compounds, since we're compounding monthly. So if you're given a value in months, you can just plug that in. You don't have to do 12 times that thing. So 12 times y, again, y standing for years, minus 1. Now when you put this into your calculator, be very careful, especially in the bottom here, to throw an extra pair of parentheses around everything that's going on here so that you make sure to divide by all of that. Okay, so let's see how this applies to our problem specifically. So our goal is to have $30,000. Our APR in this case, remember that we need to convert that APR into a percent, or sorry, from a percentage into a decimal. So we need to move the decimal 2 places left. Be very careful when you do that. We should get 0.009. So 2 zeros after the decimal and then a 9. We're going to divide that by 12. Again, this number would be different if we didn't have monthly compounds, but monthly is fairly standard. Okay, we're going to divide all of that by 1 plus, again, 0.009 over 12 to the 12 times 3 in this case, because we're looking 3 years down the line, we want this money, minus 1. And again, I'll just emphasize, put all of that in a set of parentheses, or here I use brackets, but that's pretty much the same thing as parentheses. Okay. If we do that, we're going to determine, okay, how much money do I need to put in every month? And in this case, if we do that, punch it in, we should get $822.45 if we round. Right, that's our specific value. If you're looking at this scenario and saying, how do I know it's exactly 30,000 I'll need? Well, maybe you don't. So we're trying to get a ballpark in reality. So you might say, okay, I'm going to put in 800 or 825 or 850, right? If you want to be in and around that 30,000 after 3 years.